Now this type of question actually is testing you on differentiation of Trigo and algebra. Okay, and you have to use the first two parts in order to solve the last part. Now, I'm going to modify the question a bit. You're going to try your own. First part, quite simple. You just need to know differentiate sign, you get this, so on and so forth. Integrate, then is the other way around. Okay, so I need to use product rule for this because this x is a function, this sine 2x is a function. So I use red for x and black for the Trigo expression here. So when I use product rule, differentiate the first one first, this one don't touch. Now this one don't touch, differentiate the second one. And when you differentiate sine, you get cosine. And don't forget to differentiate the argument. Differentiate 2x, you get 2. Okay, then rearrange into sine number algebra. Okay, so that's your answer for the first part. Second part, more or less the same, but now is x squared and cosine 2x. So what I need to do is to differentiate the x squared first. I get this. Cos 2x, don't touch it. Now you can add. Now don't differentiate the x squared, differentiate cosine. Differentiate cosine, you get minus sine of whatever the argument here is. Okay? And when you differentiate 2x, you get 2. So remember, don't write any argument here so that you don't make the mistake of writing sine x here when it's actually sine 2x. Next, simplify the expression sine number algebra. That's it. Okay, so that's for the second part. Now the third part, they say hence find this. Now you notice 5x squared sine 2x. Okay, if you look at the previous part, it's nowhere here. You don't have x squared sine 2x, but sine squared x 2x is here. Okay, so what you need to do is to start from here. Don't care about what they ask you to find first. You start from here. So you say from here. See, when they ask you to differentiate this, you get this, right? Okay, you state this first. So if I were to integrate both sides with respect to x, I will have this cancelling each other out. This differentiation and this integration will cancel each other out. So I will just end up with x squared cos 2x. You see, this is exactly the same as this. Plus a constant. I call it C1 because there will be other constants later. And on the right hand side, because I integrate both sides, right? Integrate this. I can just separate it as this. And integrate this. I can throw the either here inside this integral sign or outside. Okay, it doesn't matter whether it's inside or outside. Okay, but I'm going to leave it outside because I'm going to focus on what I want. Now this x squared sine 2x is part of what I want. I just need to change this minus 2 into a 5. Okay, how do I do that? I make this the subject first. Okay, and this fella, so-called, I throw it over this side, so negative C1. Okay, so I'm going to make this a subject. Now I don't want the 2 here. I want to change it into 5. So what do? I divide by 2 to everybody, divide by 2, divide by 2, divide by 2, then I times 5. Okay? Or you can straight away times 5 over 2, 5 over 2, 5 over 2, 5 over 2, you will get this. Alright? So those who are faster need not do this step. You can straight away come to here. Okay, now we have a problem already because there's no way you can integrate 5x cosine 2x. There's no such thing as product rule because this is a function, right? There's no such thing as product rule for integration. Okay, this one you don't need to integrate anymore. Leave it. This one don't need to integrate anymore. Okay, don't get confused. You only need to integrate this and you will get the answer for this. Okay, so our job now is to find out what this is. And if you were to look at the previous part, right? Part 2, part 2 don't have this, okay? Don't have this thing that you want. Part 1 has your x cos 2x. Now don't worry about the constant, okay? The constant we can easily change. Now the constant here, from here is a 2, right? We can easily change it to a 5 by multiplying 5 over 2. 5 over 2 to this, and this. Okay, but we'll do that later. So I'm going to do a side working. The side working is over here. You can see it here. Alright, so I name it side working. Okay, this side working is to work out what this is, because I already got my n in mind. I got this ready. This one no need to do anything more. This one no need to do anything more. I just need to find this red part. So I'm going to do the red part here. Now from part 1, you know that differentiate this, you get this. Okay, so if I were to integrate both sides, you see the thing that I wrote in red, I integrate both sides, right? This differentiation sign will disappear. So I'll get x sine 2x, which was what was given originally, plus another constant. You must always remember to write a constant when you integrate. Okay, this constant, because it's different from the previous constant, so I call it C2. Okay, and on this side, when I integrate sine, right, you have to be very careful. I integrate sine. Okay, I integrate sine. I will have this minus thrown over to this other side, so I'll get minus cos 2x, but I need to differentiate the 2x, then divide by the answer, which is 2. Okay, differentiate 2x is 2, right? So I got to divide. Integration, I divide. Differentiation, I times. Okay, so I hope you know how to get from here to here. This done already. No need to integrate anymore. I've integrated this. Oh, sorry, I left out. I need to plus another C3 here, because when I integrate this, right, there'll be a new constant coming out. Okay, now when I try to integrate this, I cannot integrate this, but I don't worry about it. I just separate this from this, this from this. So I've integrated this already, and it's this plus C3. This one I'm not integrated and I'm not able to integrate, so I leave it as it is. And I throw the 2 outside. Why? Because I actually don't want the 2, I want 5. Remember? I want the 5 here. So actually I can just times 5 over 2 to every term here later, but I'm going to do it step by step for you. Okay, so there's a plus C3 here. And next step, right, I'm going to divide everybody by 2. To get rid of these 2 which I don't want. I want it to be a 5, right? So divide by 2, divide by 2, divide by 2. This divide by 2 will be this divide by 2 will be this divide by 2 will be over 4. And I left out this, sorry about that. It will be C3 over 2. This is a 3, Okay? Then plus this whole thing. Okay. Then now I want a 5, right? So I times 5, times 5, times 5, and times 5. So there will be a, okay, let me just write in something that I left out just now. C5 C3 over 2. Okay? Then plus, oh here, sorry. Okay, yeah, now I got this thing that I want already, then this thing that I want already. I don't want this on this side, so I add minus 5 cos 2x over 4 on both sides. It will appear here. Okay, this was originally this was originally this, and also I need to minus of, sorry I left this out just now, minus of 5c3 over 2. Okay, and that will be what this red part is. And I'm going to transfer this whole thing to here. Now this is replaced by this. And just now I left out, right? I left out this plus 5c3 over 2. Okay, so this whole thing, now this whole thing, right, all the constants, 5c2 over 2, 5c3 over 2, minus 5c1 over 2, I can actually change, sorry, this is a minus. I can actually combine all this into another constant called c4. Okay, so that I don't have so many constants. There's no way you can find the constant, and the question doesn't require you to find the constant also, so you can just call it this constant. Okay, so right now all I need to do is this one, check, done already. I've integrated already, right? No need to integrate anymore. Don't get confused, don't go and integrate all this anymore. There's no need to integrate anymore. Once you have integrated, here is done already. Okay, done already. And this one already done, earlier part done. So that's your answer.